Right here we're going to show some of the difficulties in the work as it goes along. We can see we got on right now what we're looking at, phase 1, 2, and 3. We've got a normally high reading on phase 1 for an unenergized field, 0.7 amps. And the reason we always rely on 3 background stator line meters is to let us know if some kind of foul-up has not taken place, in which case a foul-up has taken place, and we can see that we only got 0.1 volts on phase 2 and 0.1 volts on phase 3, but we still got amperage on phase 3 due to the fact that it's being induced by the adjacent layers on the 3 pancake coils, which are consecutively numbered, phase 3 on top and phase 1, 2 upwards. Now we'll go in there and fix that situation if we can quickly. Evidently a loose stator wire has come into being. Seems to have fixed that. And now today we're going to look at the 2 different varieties of energizing the secondaries. Right now we got 5 incandescent bulbs loading down the secondary. The incandescent bulbs are not yet hooked up to the circuit. Circuit forms LC loop with the top coil and 50 nanofarad of capacity. The meters rest on the capacity. Right now we can see that there's 56.8 milliamps of circulation in that LC loop. Correspondingly, on our inputs. Our inputs are considered to be generally phase 3 because phase 3's layer is directly underneath the secondary coil. Okay. It is the amount of secondary current that in this case limits the input current. We can see that phase 3 has 1 volt enabling 0.25 amps in fluctuation. Notice that all of the phases are fluctuating in amperage. Now then we'll go back down there and look at the change of input conditions when we in fact decrease the secondary loading. The way we'll be able to decrease the secondary loading is to decrease that 56 milliamps in the secondary by adding the 5 series bulb load in betwixt the LC values or in between them, as is commonly done on taking a load from a resonant circuit. Then we'll add the bulb load. We've got 0.24 amps on the layer 3. And now notice what happens when we added the bulb load. Our input current went up to 0.5 amps or doubled. 1 volt at 0.5 amps. And remarkably, we have more amperage being taken by the bulbs, whether than the amperage in circulation. There's only 2.7 milliamps in circulation on that secondary right now. Well, we can't say that for sure. We can say there's only 2.7 milliamps going to the cap bank, which on that amperage measurement shows the interchange of amperage between L and C, and so we say that contribution is 2.7 milliamps, and the bulb contribution is 5.2 milliamps, and we generally think then that we only have 5 milliamps now going through the secondary, thus the primary is unloaded, and the primary being unloaded will act as if there is no load there. Well close to those circumstances, and then we see this is why in the background then we have the amperage meters, voltage meters, if in fact those are visible. Now, noting the nonlinear resistance, we want to be operating for maximum energy transfer at a point where the amperage going through the load does not exceed the amperage going through the loop, which has apparently happened in this instance. The cold resistance of the incandescent filaments is too low of a value, and it's acting to short out the entire resistance. Here, this, all we do is go in there and bring up the voltage input, which we will do now. A 10-volt variac, not much. 20-volt variac provides voltage into our field. We're at a 5-volt field, then we still haven't gone to filament. Take it up to a 30-volt area. And there we are at a 9-volt field, 7 to 9-volt field. Glare of the sunlight doing anything there. Should be able to see the lighting of those bulbs. And the input conditions. Now notice here, more importantly then, we want to ascertain whether that load is being obtained fairly efficiently. And we see then that we got 28 to 30 milliamps going through all 5 incandescent bulbs, and it's only taken half of the amperage in circulation across the circuit, which is an ideal situation, probably, we will suppose. And then now what remains to be done then is to add a bottom secondary in the same fashion as we've done this top. Thank you.